Hello, everybody. We're gonna wait just a few seconds to wait for the last people to join us, and then we will be able to start in a few seconds. Just to be sure, can you hear me well? If you can just send a message in the chat just to confirm that you're hearing. Perfect. Thank you very much. So the microphone is off. If you have any question during the presentation, don't hesitate to write in the chat. I've got a colleague with me, Vincent, who is in charge of the chat. He will be able to ask me the question or to reply directly if necessary. So we're gonna start now. Thank you for joining us today. So the idea today is to introduce a little bit more our software Websprint and its capabilities. So we're gonna have a look on the different modules today. As we have developed regularly Websprint, we're gonna have a look at it and see the new modules and new functionality that you probably didn't know. So first of all, before continuing, I will have a quick word about Soul Solution for those who didn't know us very well. So Soul Solution is a geotechnical engineering company based in France. Today, we are about 90 people working in the company. We have two main activities. One is the equipment manufacturing and sales. And then we have also the services part. So we are doing services with all our products. We are doing services in the radar industry, geotech investigation, retaining walls. So we have many different activities, but for all our activities, we are using, in general, the dynamic compenetrometers. Recently, a few years ago, we have launched also a new activity, which is a software editor, and we have developed Websprint. At the beginning, we have started with just 3 modules, and today we have something about 7 modules. So we're going to start about the software. I'm going to share my screen and display the different functionality of the software. If there is any question during the presentation, don't hesitate to ask on the chat, and we will have also time at the end of the presentation to make a discussion. So normally you should see my screen. So this is Websprint. Websprint is our geotechnical software. It's a web-based software. So you just need email and password to connect, and then you can connect on all type of support. Your computer, smartphone, tablets. So you just need email and password, and then you're able to go everywhere in the world. Websprint is today split into 2 parts. The first one is DataSprint, where we're gonna store all the data, and MindSprint, where we're gonna process them. We're going to have a look on the different modules and see the different capabilities of these 2 parts. So if we start by DataSprint, DataSprint is the part where we're going to store the data. So we're going to have the list of all the projects from my company. Websprint is a collaborative tool. So I'm going to have access to the data from my colleagues, and they're going to have access to mine. For example, I've got the list of all the soundings for the company, so I can have soundings from my colleagues Philips, Lisa, and so on, and they can have access to mine. What is interesting too on this part is that you can find all your data on a maps. If I open this, you can have a look on where we have been doing demonstration, where we have done some tests, and then we have soundings in all these places. It's easy to find a project. Here it's worldwide, but if you're looking for a specific project in some region and you can't remember the name of the project, you just have to scroll, zoom on the place that you want to check, and have the view on the sounding that you want to see. Here are the different projects. So let me open one, which is complete. It's an example project. So on the example project, we're going to have different parts. Summary, we're going to have the view on the different soundings. So on this project, which is an example, it's not a real project, We have projects with Panda soundings, Grizzly soundings, Kodiak soundings, or the device made by Salt Solution, all our DCPs. We have also the maps with the location of all the soundings. If I press 1, I've got a quick view on the graph. I've got the possibility to move the geolocation, to add pictures, maps, drawings. But what is interesting in this part will be the visualization. If I press visualization, I'm going to have the look on the different projects, different soundings. So for example, if I open this one, I've got my penetrogram. So we have the cone resistance against the depth. We have the possibility to apply, to process the data. For example, if I want to smooth the graph, if I want to regularize, to clip the graph. So I've got different possibility here. What is also interesting, it's also the possibility to have the possibility to overlay the soundings. So here, for example, we have overlaid the 5 soundings, and we can see that they have the same profile, which is interesting for our project. If we go back to the beginning, here we got information, data, appendix, pictures, plans, report, miscellaneous. It's where you can store all the data. The idea is to store all the documents related to this project. Pictures, maps, drawings, you can store them here. And at the end of the project, when we are going to be able to generate the complete report, you're going to be able to select the data, the pictures, and the things that you want to add to your report. But this is only DataSprint. In DataSprint, we are not processing the data. We are just checking them and visualize them. Then we're going to move to MindSprint to process the data. In MindSprint, we're going to have different modules. So we're going to have modules for the Panda, but we're going to have also modules for other devices. At the beginning, when we launched the software, it was only dedicated to our own device, but today we have some modules where you can add data from SPT, CPT, from pressure meter. So the idea is to be able to integrate data from other devices to be able to process them. So we have different modules available. We have compaction control, where we're going to check the compaction of the soil. Soil investigation, where we're going to be able to make the geological profile and see the bearing capacity of the soil. We have correlation, where we're going to be able to make some correlation with different devices, different techniques. Bearing capacity control is the modules developed for lightweight deflectometers and static plate load test. Liquefaction risk and shallow foundation are 2 modules where you can add data from different devices in order to make a study about liquefaction and also estimate your foundation if they are adapted, but we will see that more in details right after. And laboratory is the last module that we have launched. It's the module that will help you to classify your soil. So today we're going to see all of them quickly because there is a lot of things to see and we have just 1 hour. So I'm going to be quick on each module. Feel free to ask if there is any question during the presentation. Let's start by compaction control. So the idea of the compaction control module will be to check if the compaction done by other company, for example, is correct. So on every module of the software, it will work the same. You will be guided. First step in this, the module will be select the sounding that you want to process. Second step, here, for example, we are working on the Panda data. So let's say these 6 soundings. Second step will be to create the backfield. Here, we have a list of backfield models that we have created. For example, here I've already applied one here with different classification. If I want to add a classification, just press the add button, select the soil classification that I want to work with. I can put the weights, the type of networks, and so on, and then create different layers. So let's say 0.3 meters of GW material, hydrostat medium. Quality, I want to reach 98% of the optimum proctor. I add another layers, 0.3 GWGM this time in sensitivity to water, and I want to reach 95% of the optimum proctor, and 0.4, let's say another material, SW in sensitivity to water, and here I just want to reach 93% of the optimum proctor. I can add a pipe, I just give him a name. Okay, I can confirm, and then I will be able to apply this specification to my soundings. So I say that I want to apply to all of my soundings. Sorry, the connection is a bit long today. Okay, it's done. And next step will be to check if there is any anomaly in the compaction. And here, with this specification, I can see that all my soundings are acceptable. So to understand if the soundings are acceptable, they need to be on the right side of the green line. If they are on the left side of the red one, that means that the compaction is not good enough. But in this example, all the soundings are correct. And last step will be to generate report. So I can generate a complete report, generate a map, or generate just a test report. If I generate a complete report, I will be able to select all the information that I want to display. I can put the customer's logo, all the addresses, date, comments. I can add some comments if there is something to add on these things. I can add some pictures, some drawings, and so on, all my comments, appendix, and then my conclusion. I will generate the report, and then we will be able to see what it looks like. So this is the only step that takes a few seconds in the software, just the generation of the report, but you will have something very complete very quickly, and we will be able to see it in a few seconds. So it's almost done. Here it is. We just have to download it, and then we have our complete report. So the report will look like that. So we have all the information about the date, the name of the project, the site, a quick summary, the information about the document, the data, all the acceptance criteria, the pictures that we have had, the list of our sounding and if they are acceptable, and each sounding with the pictures, the location of the soundings, and the graph, and the specification that we have defined. So this is for the compaction control module. Is there any question about this module on the chat? Okay, my colleagues told me that it's okay, so we should be able to continue to the next soundings, next module. So next module is the soil investigation. So soil investigation, it's quite simple module, but interesting for some aspect. As I told you, the idea of this module is to be able to make the geological profile and also to have the estimation of the bearing capacity. So for example, if I open it, as I was mentioning before, different step, soundings, geology, bearing capacity, reports. So here I've got the list of my sounding. Next step will be to create geology. So as it's already a project that has been created before, my geology has been created. For example, here I've got 1 meter of clay, 2 meters of loss, and 2 meters of sand associated to this. This is not mandatory. It's something that you can add if you want to add this info. You can import your geological profile from other parts of the software also. But what is interesting is to see the bearing capacity. Automatically, the software will calculate the bearing capacity of the soil at every depth. So it's done by this calculation, which is here. You have the toolbox explaining where does it come from. And automatically, it's calculate the bearing capacity based on the cone resistance. So the idea is to have something very quick. You just import your data. If you want to add your geological profile, you can. And then you will be able to see all the information about the bearing capacity. Here you can see a green line. It's just, for example, a threshold that we have defined. If we know that we need to be more than 1.5 kPSF, you have the line and you see that to be above, you need to go at 3.5 meter deep. Of course, something that I've not mentioned, but we have a lot of people from different countries. We have a lot of units available. We can work in metric system, imperial system, but for example, for the bearing capacity, we can put it in bars if you prefer bars, or you can adapt to many parameters, many units. Here, for example, it's in bars. And next step will be to generate reports. So here I've got already some report that has been generated. So let me just show it to you. So we have the geological profile. And then we have the graph with the geological profile, the cone resistance get by the Panda in this case, and the estimation of the bearing capacity. So in this case, I've just generated one report for one soundings, but if you have 10 soundings, you will have the same things for the 10 soundings with the location, all the data, date, depths that you will average, and so on. So this module is pretty quick, pretty simple, but interesting for this. I'm going to ask Vincent if there is any question in the chat.
Yep. What bearing capacity is given? PC rated to the cone shaped used?
Sorry, I didn't understand the questions.
What bearing capacity is given? PC rated to the cone shaped used?
It's giving the bearing capacity of the soil. So direct estimation of the bearing capacity at the different depths. I don't know if it answers to the question, but it's based on the cone resistance. If it's not clear, we can discuss this topic right after. Okay, we can discuss this a bit later, Luis, if you want. Is there any other questions?
What happens to the profile if I only did Panda tests without a borehole or trial pits?
You mean if you don't have any geology profile to add, I guess? So for that, if the question is it necessary to have a borehole to be able to classify the type of soil? To get the bearing capacity, it's not mandatory. The bearing capacity not related to the type of soil, only the cone resistance.
Can the Panda penetrometer be a substitute for the dynamic plate test lightweight deflectometer?
Yes, it can. It will not give you the same results. It's something a bit different. We are not measuring the same thing, but it's what is interesting with the Panda is that you can measure deeper. The lightweight deflectometers, you will be limited to the depths. Here you can go as deep as you want, as long as you remain in the range of the Panda or the Grizzly, for example. Okay, so we should continue to the next module. Next module, which is, I think, interesting for geotechnical investigation. So the next module is the correlation module. The idea of this module is to estimate what can be the results with different techniques, different parameters. The Panda, the Grizzly are very interesting tools, but they can't give you all the data that you need. But some device, sometimes you cannot go there, you don't have the tools, and the idea of this module is to be able to estimate what could be your results. So, for example, if we start this module, the first step will be to determine what parameters we wanted to get. So the first parameters that we can have geotechnical parameters. So we have parameters like drag build density, friction angle, shear wave velocity, endurance shear strength. So all these parameters, you have a correlation behind. We have also parameters for soil bearing capacity. We have, for example, odometer modules or CBR index. And then we have parameters like other tests, like CPT, SPT, pressure meter, dynamic cone penetrometer. And then we just, for example, in this case, let's say we want to estimate the bearing capacity, the estimation of the CPT. I press this. I'm going to select the sounding that I want to process. So here I've got two soundings up to 6.5 meter. Here, the contrary of the previous module, it will be necessary to have the geological profile because some correlation apply only to some type of soil. For example, if I apply a correlation for sand, it will be a different one for clay. So here, it will be mandatory to have the family of soil. For example, if I add the layers, let's say I've got clay up to 3 meters, and then a sandy material up to 6.5. So automatically, I've got my geological profile on the side. And last thing will be to select the correlation that I want to use. So just pressing this button, you will have different correlations. So the correlation come from different way. For example, some have been developed by Solve Solution by our own experience, but some of them have been published by some scientific, some professor from university that has been looking on this particular correlation. And when we have some papers and we are sure of the correlation, we are able to implement it in the software. So here, for example, we have correlation for soil, all soil, sand, clays, gravels. So let's say the first layers was clay, so I'd select this one. So I've got this type of formula, and then these factors, and I can apply. For the sandy material, I'm going to select the correlation for sand. So we have a correlation with different factors. Of course, these are based for some soil, but if with your experience you are not agree with us, it's quite easy. You just modify. If you say that it's 0.1 instead of 0.15, you can apply and automatically get estimation of the CPT results. So then we press finish. So we're going to have the look on the graph, the estimation of the QC. But if we want to add another parameters, you just have to do the same. For example, if we want to add the CBR index, we do the same. Just do the geology. Add the layers. So let's say clays up to 3 meters. And sand up to 5, to 6.5, sorry. Go to correlation, calculation. Select the correlation that I want to use. So here in this example, we have correlation for CBR all type of soil, one more dedicated to clay high soil, so for this one, and one dedicated to clay low soil. So I'm going to use this one. I can apply, and then automatically I've got exactly the same than before. And what is interesting is that you can have all the parameters right next to the other one. If you visualize, we're going to have the graph like this, the cone resistance get with the Panda, the QC estimation, and the CBR information. For example, if you want to get CBR value, it's already integrated in the Panda, the terminal. You just have to configure it, and you can have directly the results on site. It's only for the CBR value, if you're interested in this value. Any questions?
Yes. Have you tested Panda correlation to CBR and the dynamic plate test correlation to CBR?
Sorry, I didn't get the questions. Is there any more details or? No. If the result given, the question is the result given by the plate load test is the same that the one given by the Panda, the CBR value?
Another one. I have a question regarding the soil library for the rheological profile. We can use our own soil determination, Slovenian language, but for CBR and other correlations, we cannot use the same soil naming. Is there any workaround?
I don't think so. As for the correlation, we just need the family of soil. It's just the family that you have to fill. If you have more questions regarding this topic, we can just send us an email at the end, and then we will be able to discuss more in details. But normally, for this module, you just need the family of soil, so no need to add more information about the specific soil. So next module will be the bearing capacity module. Bearing capacity control. So this one is dedicated to plate load test and static plate load test. So in this example, I've got only lightweight deflectometer soundings. So I've got 10 soundings. I'm going to move to the analysis part of the modules. So here I'm able to check the information that I want to get. For example, I want the VQ and the CBR. So I just select this one. And here I'm also able to edit the conformity parameters. So for example, I've got one threshold. I want that the EV2 is 20 MPa. Automatically, you will have the list of the soundings with in red the ones that are not compliant, and in green the ones that are compliant. And also, on the maps, you have all the location of the soundings, the green one or the one that match the criteria, and the other one that are not good enough. And then you will be able to generate complete report will look like this, and just the graph with the maps and the list of the soundings and the ones that are correct. So this is for plate load test and lightweight deflectometers. No questions on the chat?
We have a quick question. The correlations available are only linear. Is that the best estimation? Correlations?
It's for the correlation module?
Yeah. All the formulas are linear.
No. There is different type of formula. You can have linear, quadratics. I didn't show you. I'm gonna go back to the modules. If you want to create your own formula, that's possible. I didn't mention it. But when you're at the beginning of the software, the modules, here you have my formula. And here you're going to be able to create your own correlation. So for example, let's say that I give him a name, the QD as an entry in MPA. Output, I want geotechnical parameters, drag build density in kilonewton per cubic meters. It's applied to clay and sand, for example. And here I've got the possibility to use linear, power function, Neperian logarithmic, exponential function. So I select the correlation, the type of expression that I want to use, and then just have to configure the data that I want to add. I don't know if it's answer to the question, but no, it's not only linear expression. On the correlation that I've shown, maybe it was just linear, but you have different correlation and different type of formula. Okay, so let's move to the next one. Next one is we keep this one for the end. We're gonna see the shallow foundation. Shallow foundation module is the module dedicated to estimation of. The idea is to estimate if the foundation that you have decided or adapted to the soil and the building that you're planning to develop. So when we open this project, sorry, I didn't press the right button. So I'm open this project. Here. So here I can create a new calculation model or reuse some that are already available. So if I open this one, so here I've got all the conclusions. So let's back to the beginning. We're gonna edit the model. So first things will be to put once the location of your project. Here, for example, it's based in France. So okay, that's the first step. Second step will be to add the geological profile. Here we have 3 different types of clay with different depths. And here we're gonna add when you add the type of soil, here you will have to add the apparent bulk density. So here, as we have only clay soil, we have put 18 for all the layers. We can add also the groundwater tables. You just have to press to enter the value, and then it will be taken into account in your calculation. Next step will be to define your project. By defining a project, we will need to define the geometry of the foundation. So we are able to make different sizes of foundation, square, rectangular, spanning, circular. And then we're gonna put, here we have selected circular foundation. So the depth will be 1 meter and the diameters of the circular foundation will be 0.8. So I confirm and leave that. And last things will be to select the sounding that we want to process. So here, for example, in this module, we are not only working with our own data. For example, we are able to integrate data from other devices. Here, for example, I've got pressure meter soundings. I've got grizzly soundings, and I've got another grizzly sounding. So let's say I want to process these grizzly soundings. I will go to the calculation part. For the calculation settings, here it's based on a French document. Here, everything is filled automatically on the first page. Then second page, we will need to put some alpha coefficient and report between QD and QC. So here we take the hypothesis that the QD and the QC are similar, so we just put 1. If for different type of soil, it can be a bit different, 1.1, 0.9, you can modify this. The coefficient alpha, you have this toolbox that is explaining which data you need to put. So once again, this project has already been done. If it's the first time that you are doing it, you will need to fill this information. Next things will be to process your penetrogram. We in Solve Solution are used to work with the raw data, but in some country, for some customers, working with raw data, it's not common. So you can, for example, smooth your graph, you can regularize it, you can clip it. There is different possibility. So if you want to put one of these processing on your penetrogram, it's possible. The next things will be to estimate. Here it's an hypothesis. When we are doing foundation, circular foundation at 1 meter's depth, that means that we need to have information up to something like 7.5 meters. Our graph stop at 6.5. So here we're going to take the hypothesis that the value will be constant at the end or variable. So let's say if it's variable, it starts at 33 and it will finish at 35. So your graph will be adapted like this, or it will, if you think that it will reduce, for example, and go to 15, you can adapt, and here you will have to take hypothesis. This will be your responsibility to estimate it. So let's say it will be constant for this example. Next, I will have to put some lot case. So here we have put 2 examples. So in different weight, different what you say it, lot case, let's say. So here we have put 2 values, and I'm going to start the calculation. And automatically the software will check the bearing capacity. So here there is no problem with the bearing capacity, eccentricity, no problem, and sliding, no problem. So that means that the foundation are adapted to the building that you're planning, and also the soil that you have. But here we have a good example for if I want to modify and check if it's I want it to be wrong. Let's say on my project, I will say that instead of putting the 0.8 as a diameter, I would put 0.4, so reduce the size of my foundation. Confirmed. I go to mechanical data, calculation settings, and start calculation. So just by reducing my foundation diameters, it says that there is problem with bearing capacity. And you will have some settlements, some like 46 millimeter settlement, which is quite a lot. So that's not acceptable. Questions?
Are these estimations based on SLS or ULS?
I think you mean ultimate limit state, and so here in this example, it's not based on that if I'm correct, but I need to check. I will have to check with my colleagues, and I can give you a feedback. I prefer not to say something wrong. I will double check with my colleagues. Or maybe if my colleague Tamara is in the chat and she has the answer, maybe she can answer it, but I prefer to leave it to Tamara. Okay, and for example, this is, no, not this one. Sorry, not one. This is the type of report that we will have at the end. So we have the, oh, sorry, I generated in French. I will generate it in English. So here we just have to press reports, generate a test report, and I'm gonna have it in English. So here, if you do different profile, different models, you can be able to display all of them. So for example, I will display 2 of them. I don't know if the second one is interesting or not, but this will be the type of result that we will get. So you have the different layers, different soil information, density, coefficient alpha, QDQC report, the foundation that you have determined, where does it come from? So DTU 1312, the soil behavior, and then you have all the information. So here we have put 0.4 meters of diameter. So here we have not problem with the bearing capacity, and then all this information. So that's how the report looks like. So time now to continue to the next sounding if there is no other questions. So the other module, sorry. So for the next module, we're gonna have a look on the laboratory modules. The idea of this module is to be able to estimate the type of soil that you will have. So here, everything has been filled before, it's just for the demonstration, for not losing time on completing everything. So we have different tests that are integrated in the software. So we have the water content, granulometry, VBS, but it's more used in France, Atterberg limit, Proctor, and CBR. And then we will be able to determine the classification. So we have different soil classification, the French one, GTR, but we have also HTO and USCS specification, but we will see this at the end. In this module, you will have to, every time you have this pen, you press it, and you just have to complete. So here in this example, to determine the water content, we just need to put the weight of the container plus the wet soil, and then the weight of the container plus the dry soil when it has been in the oven. When it's done, you complete this, and automatically it will calculate the water content. If you have information from other systems, you just be able to put it manually. In this case, we have filled all this information and been able to determine the water contents. If we move to granulometry, here it's taken into account that the previous info about the water content. So we will have the information when we are cleaning the soil. Here, just fulfill the info as previously. So the container plus wet soil, and container plus dry soil. And then it will determine this value. And to finish, we will have to complete information about the theme. We have different methods, individual and cumulative. Here we are at the individual one. So we have the weight of each container plus the weight of the container plus the dry soil. So we are able to put that for all the type of sieving. You can add your own one. You can determine if you know the weight of your own. You can set it up only once, and then it will be saved in the memory. And every time you just have to fill a few information. You can confirm, and automatically the software will trace the granulometric distribution. And you will have some information. At every test, you can add pictures. We have the same for VBS, Atterberg's limit, Proctor. For example, for the Proctor, we have something that is interesting. This is this calculation assistance. So you just put the weight of your container. So for example, 0.2. The weight of the container plus the soil, 1.5. The initial water content, we were at 13.5. And I want to reach 15% of water content. So for that, I will need to add 0.02 kilogram of water for the next test. So this is quite easy to add this information and to calculate the quantity of water that you need to add. Then you just have to fill all the information. If you are using Proctor, normal, modify, which type of mold, if it's CBR or Proctor, the classification that you are using, here it's international classification, confirm, and then on each layers, you just add the characteristic and the water content. So for those who are used to work with laboratory tests, it's quite easy. Just need to complete a few data, and at the end we have here, for example, the Proctor curves with information about here it's almost 12%. And the same is for CBR. When we have filled all this information, next things will be to, it will calculate the classification. So if we are based on the French classification, it's a soil B2. But if we are wanting to get information about the USCS classification, all the information that I filled before give me a SC soil. So for that, we have all the information necessary for that, the liquidity limits, plasticity index, and the information about the granulometry. So this is quite interesting to be able to estimate your type of soil. No question? Perfect. And this is all the report looks like. When you finish your test, you generate a report. It looks like that. And then you have the summary, you have the different information about the water content, the classification, B2, if it's a H2O classification, it's a 827, if it's a USCS, SC soil, and so on. And then you have all the test report, all the information, everything on one document. So now it's time to move to the last module. The last module is the liquefaction one. So we are running out of time. So I will be very quick on this this module. So for example, if I open this project, sorry, I'm not in the good part of the software. Here, so here I've got different calculations. So once again, this module is not only used for Panda or Grizzly. It's you can implement CPT info, SPT info, and process your data. So I just wanted to open here some, just looking for interesting graph. But here you're gonna have, it's like the module, the foundation module. You have to fill some information about the calculation. If there is an exponent, K-limit, different methods. If you want it to be based on CPT method, if you want to be based on SPT method, there is different methods, Le Petit method, modified, and so on. Or for the tailing dams, for example, you have all the processing that is possible, like before, clipping, smoothing, regularization, raw data, all this. And then we have also the models to be defined. So the location of the soundings, the geology of our site. So if we want to have a soil that will be able to liquefy, it needs to be a sand. And we have the water profile, water here at 1 meter depth. Here we can define our project. For example, on this project, we have said that we have 1 meters of embankment, and then select the sounding that we want to process. So as I've mentioned before, here, for example, we can process Grizzly soundings, but we can also process CPT soundings. So all of these soundings are CPT. I can select this one and then switch to liquefaction calculation. And here, automatically, it will make some investigation. Just to show you the right info, here is the example of a report. So we have all the information, the geology, the type of facilities and works that we are putting on the top of this, and all the calculation hypotheses. So here we have the safety factor that will be displayed, the liquefaction potential index that will be displayed, here a conclusion that there is a high risk of liquefaction in case of earthquake. We have taken an assumption here, there is a magnitude of 7.651 with all these values. So there is a lot of value to configure, but when it's done, you will have this type of graph with your con resistance here based on the CPT, the CRR versus TSR value, the safety factor, all the seismically induced settlement, and also liquefiable height. Sorry, it's a bit complicated for me. It's the end of the day. And here you have all quite information about all the graph that you have below. So that was the last module that I want to show you today. We are right on time. We have 50 minutes for the questions. So what we can do is probably switch on the microphone. And let's see if there is any questions. Okay, so normally you should be able to open your microphone.
Hello.
Hello?
Yes, please. I wanted to find out, or maybe this could be in the future progress, how possible it is, like if I assess the bearing capacity and I want to determine, like I want to design a foundation, how is it possible to import the data from the analysis of the bearing capacity and I move it directly, or I retrieve that data from the other analysis and I move it to another, in a way that I can start by estimating the soil parameters or the lab results, estimate the bearing capacities and assess the foundation design using the very modules instead of inputting different data. Thank you.
Sorry, I didn't catch all the question. The sound is not very good. I think it's a very specific question. So maybe we should discuss this topic because I probably didn't have all the answers. My colleagues will be more able to answer that. So maybe we should do that. I will contact you after Sam, maybe tomorrow.
Okay, please. Okay, please. Thank you.
You're welcome. Is there any other question that I can try to answer? So it looks like there is not a lot of questions. So just quick information about the software. It's a yearly subscription. And if you're interested by one of these modules, we are offering 1 month free. If you have participated to this webinar, you just need to mention it and you will be granted of 1 free month if you wanted to. And this before the end of March. No, February, sorry. No other questions? Should we stop? Okay, so I've seen that there is people from everywhere in the world. So thank you for the people. I think there is a South Korean people. So thank you to be there at this time. And for the other one, thank you for being there and your participation and your questions. Have a good day, afternoon, depending where you are, or good night.
Thank you.
Bye.